This video is brought to you by IXL, used by millions of students worldwide to get ahead in math, English, and more.
Today we'll be learning how to interpret functions using everyday language. Let's first talk about function notation. You might be used to seeing functions written like this, but we could also write it like this. This may look different, but nothing really changed. X still represents our input, and instead of y being our output, we say f of x is our output. So for this function, if we wrote f of 1 equals 5, that tells us that when our input, x, equals 1, our output is 5. Great! Now let's do some real-world examples. In order to raise money for the school dance, students in leadership class are collecting cans to recycle. When they recycle X bags of cans, they make f of x dollars to put towards the dance. We're asked what f of 20 equals 60 tells us. Let's start by pulling out some key information. So we're told the function f of x tells us the amount of dollars that can be made from collecting X bags of cans. So f of 20 would tell us the number of dollars made by collecting 20 bags of cans. And we know that f of 20 equals 60. So in this scenario, f of 20 equals 60 tells us that if they recycle 20 bags of cans, they will earn $60 to put towards the dance. Good job! Let's try another example. Example 2 says thanks to an online typing course, Haley has become a much faster typist. The function f of x gives how many words she can type in x seconds. We're asked what f of 45 equals 68 tells us. So again, let's look for what our notation and variables represent. We're told the function f of x gives how many words she can type in x seconds. So f of 45 tells us the amount of words Haley can type in 45 seconds, which we're told is 68 words. So to answer the question, f of 45 equals 68 tells us that Haley can type 68 words in 45 seconds. Our next example states Clarence uses a lot of sugar making cupcakes for his shop. He uses f of x scoops of sugar to make x dozen cupcakes. We want to know what f of 50 is greater than 60 means. So our function notation gives us an inequality statement here, but let's start the same way as we did in our previous examples, by finding what our variables represent. So we're told the function f of x tells us how many scoops of sugar are used to make x dozen cupcakes, which means f of 50 would tell us the amount of scoops of sugar that are needed for 50 dozen cupcakes. But we're not told exactly how many scoops of sugar are needed. We're told we'll need greater than 60 scoops of sugar. So f of 50 is greater than 60 tells us that Clarence will need more than 60 scoops of sugar to make 50 dozen cupcakes. For our last example, we're told while training for a marathon, Alice tracks the miles she runs each day. The function f of x gives the number of miles Alice runs on day x. This one is a little different again, in that we are asked what f of 9 is less than f of 11 tells us. We'll again start with some key information. The function f of x gives us the number of miles Alice runs on day x, and we're asked what f of 9 is less than f of 11 means. So f of 9 tells us the number of miles Alice ran on day 9, and f of 11 tells us the number of miles Alice ran on day 11. We don't know exactly how many miles she ran on either of those days, but we do know that Alice ran fewer miles on day 9 than she ran on day 11. Great job interpreting these functions. Keep practicing!
Head over to IXL.com for more practice on this skill and thousands more videos in math and language arts.